A useful thing to be able to do is derive the sine, cosine and tangent for some common angles. So here are the common angles here: 0, 30, 45, 60 and 90 degrees. And here is a method that we're going to use in order to be able to derive these for ourselves without using the calculator. Now we're going to start off with two triangles. The first triangle you see here is called an equilateral triangle. That is, the length of all of the sides are equal. And in this instance here, we're going to make the length of each of the sides 2. So this is 2, 2 and 2. Now the angles of a triangle add up to 180 degrees. And when we have an equilateral triangle, all of the angles are equal. So this would be 60 degrees, this would be 60 degrees, and this angle here would be 60 degrees. And when we add them all up, they give a total of 180 degrees. Now what we would do is we would drop the perpendicular from this point here down to the centre of this line. So if we drop it down to the centre of this line, we're going to split this line into 2. So the length of this little triangle here is going to be 1, and the length of this little triangle here again is going to be 1. So that means that what we've done is we've split this angle here into 2 as well. So this total angle is 60 degrees, and we've split it into 30 and 30. Now we can use Pythagoras in order to work out the height here. By Pythagoras, the height is going to be the value of 2 squared minus the 1 squared, and then we take the square root of it, and that gives us a value of root 3. So we've got all of the lengths and all of the angles that we need in order to work out the sine, the cosine and the tangent for both 30 degrees and for 60 degrees. So let's put the first one in and we'll work out the value of our sine for 30 and 60 degrees. So when we look at this little triangle, we're looking for the sine of 30 degrees. Well, the sine is the opposite over the hypotenuse. So the length opposite 30 degrees is this length here, which is 1, and hypotenuse is 2. So the sine is going to be 1 divided by 2. So that gives us the sine of 30 is a half. Now we can look at the 60 degrees. The 60 degrees is here. The sine is the opposite over the hypotenuse. So the opposite is root 3 and the hypotenuse is 2. So the sine of 60 degrees is root 3 divided by 2. Now you can look at the cosine. The cosine is given by the adjacent divided by the hypotenuse. So the cosine of 30 degrees is going to be given, well, the length that's adjacent to the 30 is the root 3 and the hypotenuse is 2. So that's going to be a value of root 3 upon 2. And then when we look at the 60 degrees, the length that's going to be adjacent to the 60 degrees is 1 and hypotenuse is 2. So that's going to give us a value of 1 upon 2. Finally, the tan function is going to be given by the opposite divided by the adjacent. So for 30 degrees, we're going to have the opposite, which is going to be a value of 1, and the adjacent is going to be the value of root 3. So it's going to be 1 divided by root 3. Now for 60 degrees, the opposite is going to be root 3, and the adjacent is going to be a value of 1. So that's root 3 upon 1, which is just root 3. So that's us got the values for our 30 degrees and our 60 degrees from this little triangle, we can get the value for 45 degrees from this triangle. So if we draw a triangle of length 1, and this length is 1, and this is a right angle, then this is all we need to remember. From this, we can work out the other length here. By Pythagoras, it's going to be 1 squared plus 1 squared, and when we take the square root of it, we're going to have a length of root 2. Now, if this is length 1 and this is length 1, again, the angles of a triangle add up to 180 degrees. So this is 90 degrees here. So it means that this angle here and this angle must add up to the other 90. And when this is length 1 and length 1, we're going to have these two angles will be equal. So they must be a value of 45 degrees. And this one here will be 45 degrees. So now we're looking for the value of the sine of 45 degrees. So let's say we pick this angle here. Then the sine is going to be the opposite divided by the hypotenuse. So the length opposite this angle is 1, and the hypotenuse is root 2. So the sine of 45 degrees must be 1 divided by root 2. Now we're looking for the cos of 45 degrees. So if we again take the angle 45 here, the cos is given by the adjacent divided by the hypotenuse. The adjacent to this angle here is length 1 and the hypotenuse is root 2. So again, that's 1 divided by root 2. Now the tan of 45 degrees is going to be given by the opposite divided by the adjacent. So the length opposite the 45 degrees is 1 and the length adjacent to the 45 degrees is 1. So we're going to have 1 divided by 1, which is a value of 1. So that's us worked out the sine, the cos and the tan for 30, 45 and 60 degrees. Now we can get the 0 degrees and the 90 degrees if we're able to draw out the sine, the cosine and the tan functions. So let's draw those out now. So as I've said previously, you should commit the sine, the cosine and the tan functions to memory. So let's draw the sine function out, and we just do this roughly by hand. So we'll draw our axes in, and we know that the sine function starts at 0 and it's a wave that looks like this. And this is 0 degrees, 180 degrees, and that's 360 degrees. And the height of it is 1, and the height here is -1. So if you can remember this, then that's all you really need to remember about your sine function. So the sine of 0 degrees is, well, the height of this function at 0 is 0. And the sine of 90 degrees, well, if this is 180 degrees here, then halfway along here is the 90 degrees. And we're going all the way up to a value of 1. Now, we want to be able to draw out the cosine function. So again, we'll draw our axis in. And we know now the cosine function starts from a value of 1. And it looks something like this. So the cos of 0 degrees, well, at 0, the height is 1. And the cos of 90 degrees, well, this is 180 degrees here. And this is a 360 degrees. So if this is 180, then half of it is 90. So that point there is 0. So the cos of 90 is 0. Now we'll do the same for the tan function. We'll draw out our axes. Now the tan function is one that people tend to forget. the tan function starts off at 0, heads off to infinity, and then comes back in from the negative direction, from minus infinity back up to 0, heads off to infinity, and again we have the negative direction, it comes back up from minus infinity back up to 0. So if we look at the tan of 0, well, at 0 degrees the tan of 0 is 0. And we've got 90 degrees here, 180, 270 and 360. So this is the 90 degrees here. So the tan of 90 degrees is undefined. So it could be a value of plus infinity and minus infinity. So this is an undefined value. So we'll just put down the value of infinity. So in order to derive these common angles for sine, cosine and tan, we need to remember a few things. The first one is an equilateral triangle of length 2. From that we can derive all of the angles and all of the lengths, and from those we can work out the sine and cosine tangent of 30 and 60 degrees. The second thing to remember is a triangle with two sides of length 1. From that we can work out the angles are 45, 45 and the length is root 2. And this is going to allow us to work out the sine, the cosine and the tan of 45 degrees. Finally, what we want to be able to do is draw out the sine, the cosine and the tangent function. From these drawings we're going to be able to work out the sine, the cosine and the tan of 0 and 90 degrees.